In this part of the tutorial, we will see how to use PyDocking. The word docking was derived by naval docking. It involves mooring the ship to a pier, wharf, or quay, structures extending from the shore, where it can be safely accessed for supply replenishment or maintenance. Molecular docking is similar, but three-dimensional, like inserting a key inside a lock to open a door. Being a structure-based approach, you need to have a protein to dock the molecule into. Go watch part 6 of the tutorial if you don't know how to import proteins inside your dataset. To start docking your molecules, press on the button, Make a Docking. Molecular docking programs like Sminer or Plants will handle the docking procedure automatically, but sometimes they can fail, placing the molecule incorrectly or outside the binding pocket. To get better results, we practice docking validation, in which we test all the docking programs with all their scoring functions to find the best one for this protein complex. In docking validation, we flag this box to activate redocking. Essentially, this will try to place back the original ligand we retrieved from Protein Data Bank from a random position. Since we already know his correct pose, we can measure how good each program is at placing it back inside the pocket exactly. Always select the key to build the box here as the original ligand. This will focus the program around the active pocket only, where the original ligand used to reside. Select the correct protein as the dock. If you have minimized it, select the minimized protein. Now perform 6 validation docking, 3 with the SMINA scoring functions, which are VINA, Venado, and AutoDock 4, and which plants which has PLP, PLP 95, and CHEMPLP. Good. Now that they are all completed, we can see from our MSD here which one is the best. Lower is better. Also take a look at the minimized RMSD and see if it gives lower scores. As you can see, Sminer with VINA is the best one in this situation. Click on the results text to see the docking in 3 dimensions. As you can see, it placed it back in position nearly perfectly compared from the original crystallized complex downloaded from Protein Data Bank, which is depicted in red. Now we shall dock all the molecules of the dataset inside the pocket. We can use the best program with best scoring function to perform the docking on all the dataset at once. Make a new docking. Remember to check the key and lock in the selector in the bottom of this page. This time, deselect the redocking flag to dock all the dataset. Press Submit. This can take some time, so grab a cup of coffee and be patient. Remember to refresh the page every now and then. As we can see, the docking is now complete. We can see the results by clicking on the underlined results text. Since we don't have the crystallized complex of those other molecules from our dataset, we can't rely on the RSMD like we did in redocking. This time we can look at the percent overlap of the molecules and maybe compare from different docking on the same protein and dataset. Also check the minimized docking result by clicking on View Minimization Results and see if it gives better volume % overlap of the molecules. Now we can press on the button Generate Best Docked Dataset. This will be essential for the next part of the tutorial where we will see how to make combine models.